Hello friends, I am Professor Swanan Dopre and in this video we are going to study the configurations of BJT. As we know that BJT has three terminals, first is emitter, second is base and third is collector. But if you consider any electronic device, say in our lab we are using function generator or a signal generator, second we are having power supply. So if you consider such devices, at input side it has two terminals and at output side it has again two terminals. For an example, regulated DC power supply. At input side there is AC supply, so that is why two terminals are the phase and neutral, and at the output side the two terminals are positive terminal and negative terminal. So here we require four terminals. But if we consider the BJT, we have to use BJT as a switch or as an amplifier in a circuit, right? So that circuit will have two input terminals and two output terminals. But in BJT we are having only three terminals, emitter, base and collector. So what to do? We want four terminals, but BJT has three terminals. The solution is that take one terminal of BJT common between input side and output side. So based on that, which terminal is taken common between input side and output side? There are three configurations in BJT. First is common base configuration, CB. Second is common emitter configuration, CE. And the last one is the common collector configuration, CC. So in BJT, we are having three configurations. First one is the CB configuration, that is common base. Second is CE and third is CC. These are the three configurations of BJT: common base, common emitter and common collector. Now let us see what is the difference between these three configurations. We know that out of the three terminals, one terminal will be taken as a common between input side and output side, that is known as common terminal. Out of remaining two terminals, one terminal will be at input side, that is input terminal, and second terminal will be at output side, that is output terminal. So let us see in each configuration which is the common terminal, which is the input terminal and which is the output terminal. So first point, the common terminal. The common terminal. So in CB configuration, base is the common terminal. In common emitter configuration, the emitter is the common terminal, and in common collector configuration, the collector is the common terminal. So it's very easy, but the confusion will be in between remaining two terminals, which is the input terminal and which is the output terminal in each configuration. So what we have to do? Just remember one simple trick. Do you remember we have seen that in the transistor, the area of base is smallest, then there is area of emitter is moderate, then the area of collector is highest. So you have to just remember this, and with the help of this trick we can easily remember the input terminal and output terminal. So in any configuration, one terminal is common, so leave that terminal. There will be another two terminals. Out of these remaining two terminals, the terminal which is having highest area, out of remaining two terminals, the terminal which is having highest area, take that terminal at the output side. Now let us consider common base configuration, CB configuration. In CB configuration, base is common. So forget about this base terminal. The remaining two terminals are emitter and collector. Out of emitter and collector, the collector is having more area. So take collector, treat collector at the output side. It is just trick to remember this configuration. So here in common base configuration, the output terminal is collector terminal. Now if you consider the input terminal of common base configuration, obviously the third terminal, that is emitter terminal, is the input terminal. Now let us apply the same trick to the common emitter configuration. In common emitter configuration, forget about emitter, remaining two terminals are collector and base. Out of this, collector is having more area, so that is why in common emitter configuration, collector is the output terminal, base is the input terminal. If you consider common collector, out of remaining two terminals, base and emitter, emitter is having more area, so that is why emitter is the output terminal and base is the common terminal. That's very simple. So this is the input, output and the common terminals in each configuration. Friends, we know that the current flows through the circuit and it flows through the path. So that is why if you consider in transistor, the current will either flow through the emitter, or it will flow through the base, or it will flow through the collector. So hence there are three currents in transistor under DC biasing condition. There are three currents in transistor, that is in BJT. First is the emitter current, second is the base current, and third one is the collector current. Each one of them will be denoted by symbol I. I means current, subscript that terminal. For an example, IB, that is base current. So here, if we consider the fourth classification, right, the input current, for an example, input current. So here, which will be the input current in common base configuration? In common base configuration, the input terminal is the emitter terminal. So that is why input current is I. In common emitter configuration, the input current will be IB, and in common collector configuration, it will be also IB. The next, output current. So if you consider the output current, the current flowing through output terminal. Here in common base configuration, the collector terminal is the output terminal. So that is why it is output current. Again in common emitter configuration, the collector is output terminal. So that is why collector current is the output current in common emitter, and in common collector configuration, the emitter current is the output current. So this is very simple. The next parameter, current amplification factor, that is current gain. Current amplification factor or current gain. Amplification means obviously output divided by input. Similarly, gain means output divided by input. So current gain means what? Output current divided by input current. So the current amplification factor or current gain, if you consider the next parameter, that is current gain or current amplification factor, it is the ratio of output current to the input current. In common base configuration, it will be the ratio of IC divided by IE. Then in common emitter configuration, it will be the ratio of IC divided by IB. And in common collector configuration, it will be the ratio of IE divided by IB. So these are the current gains in each configuration. The current gain of common base configuration, it is denoted by symbol alpha, and here we are treating the biasing condition as DC. So that is why I'll denote it by alpha DC. Then current gain of common emitter, it is beta DC, and third one is gamma. Right, so alpha, beta, gamma, common base current gain, common emitter current gain, common collector current gain, and it's very easy to remember. Then we'll see the input voltage and output voltage. Friends, voltage is always measured or it is applied between two terminals, that is in parallel across. So that is why while mentioning the input voltage or output voltage, you have to mention the two terminals. In between those two terminals, you are measuring or you are applying that. So for an example, say input voltage. Input voltage will be applied between input terminal and common terminal, right? Output voltage, it is in between output terminal and common terminal. So what is input voltage? V means voltage. Input voltage means input terminal, then common terminal. So V, input terminal, common terminal is the input voltage. And what is the output voltage? V, output terminal, then common terminal is the output voltage. So that is why what will be the input voltage? Input voltage here in common base configuration, V for voltage, and as it is applied between the input terminal and common terminal, input terminal is E here and common terminal is base. So that is why it is VB. Here it is V, input terminal is base and common terminal is emitter, so VB. And last, in common collector configuration, the input terminal is base and the common terminal is collector, so that is why VBC. Then output voltage. Output voltage, it is applied or it is measured, whatever it may be, in between output terminal and common terminal. Here in common base, output terminal is collector and the common terminal is base, so that is why VCB. Here the output terminal is collector and common terminal is emitter, so that is why VC. And in common collector configuration, the output voltage, that is output terminal is emitter and common terminal is collector, so VEC is the output voltage of common collector configuration. So this is the detailed classification of these configurations of transistor. Here we have seen the simple trick, we have studied the simple trick, we have remembered the trick of area, and with the help of we have derived this total chart.